This is Euclid Book 5, proposition number 23, and unless you follow my instructions to the letter, what you're going to end up with is you're going to end up going outside, having to draw this thing out on a humongous piece of paper, or drawing this across your living room rug. I don't recommend either one, so why don't we just do this the right way from the very beginning. We have line A here, which is a 1/4 inch, line B, which is a 1/2 inch. We have line C here, which is 4 inches long. We have line D, which is a 1/4 inch. We have line E, which is 2 inches, and line F, which is 4 inches long. Okay. Now, let's get to the heart of the proof here. It says, if there be 3 magnitudes and others equal to them in multitude, which taken 2 and 2 together are in the same ratio, and the proportion of them be perturbed, they will also be in the same ratio ex equali. Okay, that made a lot of sense, didn't it? Let there be three magnitudes, A, B, and C. Well, we got A over here, we got B over here, we got C over here. So we got 3 magnitudes. And others equal to them in multitude, which taken 2 and 2 together are in the same proportion, namely D and F. Well, we got D, we got E, we got F. Okay? And let the proportion of them be perturbed, so that as A is to B, well, here's as A is to B, so is E is to F. E is to F. So the ratio of E to F is the same ratio as A to B. Okay? And as B is to C, B is to C, so is D to E. D to E. Okay. What we're going to try to prove here is that as A is to C, so is D is to F. D is to F. Okay. Of A, B, and D, let equal multiples G, H, and K be taken. Okay. A is a 1/4 inch. G is going to be 3 times that size, so it's going to be 3/4 of an inch. Okay. B over here is a 1/2 inch. And so therefore, H is going to be 1.5 inches, as you can see here. And we also have D, which happens to be a 1/4 inch. D is a 1/4 inch. And K is going to be 1.5 inches. Oh no, I'm sorry, it's going to be 3/4 inch, because D is a 1/4 inch. K is 3 times D. So far, so good. And of C, E, and F, well, here's C, here's E, here's F. What we're going to do is we're going to draw equal multiples of L, M, and N. Well, as we all know, C is 4 inches long, so L is going to be twice that size, so it's going to be a full 8 inches in length. Okay. Now, as we all know, E is 2 inches long, so M is going to be twice that size, and therefore M is going to be 4 inches long. And we now know that F is 4 inches long, so N is going to be 8 inches long. So far, so good. Then, since G and H are equal multiples of A and B, well, we've already established that G is 3 times the size of A. G is 3 times the size of A. And H is 3 times the size of B. Okay? And parts have the same ratio as the same multiples of them, which is by Euclid Book 5, proposition number 15. Therefore, as A is to B, so is G is to H. As A is to B, so is G is to H. For the same reason, as E is to F, as E here is to F, so is M to N. M to N. As E is to F, so is M is to N. So far, so good. And as A is to B, so is E is to F. Therefore, also as G is to H, so is M is to N. Okay? Alrighty. And we can establish this by Euclid Book 5, proposition number 11. Next, since as B is to C, so is D is to E. D is to E. Alternately, also, as B is to D, so is C is to E. C is to E. As B is to D, so is C is to E. And this is by Euclid Book 5, proposition number 16. And since H and K are equal multiples of B and D, H and K, H is 3 times the size of B, and K is 3 times the size of D, and parts have the same ratio as their equal multiples. Therefore, as B is to D, so as H is to K. So as B is to D, so as H is to K. And this is by Euclid Book 5, proposition number 15. But as B is to D, so as C is to E. As B is to D, so as C is to E. E's way up here. As C is to E, so as B is to D. Okay. Therefore, also as H is to K, so as C is to E. Okay, this here is in the same ratio as this. Again, since L and M, okay, we've got L and M, both of these are twice the size, okay? L is twice the size of C. L is twice the size of C. M is twice the size of E. M is twice the size of E. Okay? Therefore, as C is to E, so as L is to M. As C is to E, L is to M. And we can say this by Euclid Book 5, proposition number 15. But as C is to E, okay, so as H is to K. We've already established that. Therefore, as H is to K, so as L is to M. As H is to K, so as L is to M. And we can prove this by Euclid Book 5, proposition number 11. And alternately, as H is to L, so as K is to M. And we can prove this by Euclid Book 5, proposition number 16. But it was also proved that as G is to H, so as M is to N. M is to N. Since then, there are 3 magnitudes, G, H, and L, and others equal to them in multitude, K, M, and N, which taken 2 and 2 together are in the same ratio, and the proportion of them is perturbed. Therefore, xi quali, if G is in excess of L, well, let's see if G is in excess of L. It is not. It is actually G is less than L. Okay? If G is less than L, then K is also less than N. If G is less than L, then K is less than N. Which in this case it is. And G is a multiple of K, of A. G is a multiple of A. And K is a multiple of D. K is a multiple of D. And L is a multiple of C. L is a multiple of C. And N is a multiple of f. N is a multiple of f. In other words, N is twice the size of f. Okay? Therefore, as A is to C, so is D is to F. As A up here is to C, so is D is to F. And that's what we've come here to prove. Alright, I will tell you more in a future video. Stay tuned.